While non-metal are those elements that ionize by gaining electron. Non-metal are those elements that ionize by gaining electron. For instance, let's look at magnesium. Magnesium is a metal that ionize, that become ionized by losing two electrons to become Mg2 plus. The symbol for magnesium is Mg. It ionized by losing two electrons. It loses two electrons. Let's look at a non-metal like chlorine. Chlorine ionizes by gaining one electron to become chlorine minus. Chlorine gain an electron to become ionized. It gains one electron to complete a stable octet configuration to become chlorine minus. So non-metal ionized by gaining electron, while metal ionized by losing electron. Let's look at the differences between the physical properties of metal and non-metal. The differences between the physical properties of metal and non-metal. Metal, the first thing of note is that metal are malleable, ductile, or sonorous, while non-metal are not malleable, ductile, or sonorous. Metal are lustrous. This metal shine, while non-metal are non-lustrous. Metal have great tensile strength, while non-metal are brittle, soft, or not hard. Metal are good conductor of heat and electricity, while non-metal are poor conductor of heat and electricity, except for graphite. Metal have high melting and boiling points, while non-metal have low boiling and melting points, except for carbon. So these are the examples, these are the differences between the physical properties of metal and non-metal. Let's take a look at the differences between the chemical properties of metal and non-metal. The differences between the chemical properties of metal and non-metal. The first thing we should note is that metal ionize by losing electron to form cations, while non-metal ionize by gaining electrons to form anions. When we move into our advanced class, we look at what are cations, what are anions, the cathode and the anode. So the first difference between the chemical properties of metal and non-metal is metal form cations, while non-metal form anions. The second difference we should note is that metal have the tendency to displace hydrogen from an acid, while non-metal cannot displace hydrogen from an acid. Metal undergo ionic bonding, ionic combination, electrovalence combination, while non-metal undergo covalent combination. Also, metal form basic oxide with oxygen. Metals like magnesium oxide, calcium oxide, sodium oxide, they are basic oxide, while non-metal will form acidic oxide with oxygen. Let's look into compound. What is a compound? Compound is the substances that is formed from the combination of two or more elements chemically combined together. As these two or more elements chemically combined together will form a compound. Now, we should also note that the components of a compound are entirely different from the properties of those elements that forms it. And also, each component of a compound are represented in a fixed ratio by mass. For instance, water is a compound, that is H2O, represented in ratio 2:1. That is, we have 2 ratio of hydrogen to 1 molecule of oxygen. 2 molecule of hydrogen to 1 molecule of oxygen forms water. Let's briefly take a look at some compound examples, their component elements and their formula. Compounds, some of our compounds formed, the component elements and their formula. Let's look at compounds, component elements and their formulas. For instance, we have water. Water is a compound, and the component elements in water is hydrogen and oxygen. The formula is H2O, which means we have 2 molecules of hydrogen and 1 molecule of oxygen forming water. Also, let's look at sand. Sand is also common compound, familiar compound. It contains silicon. Sand contains silicon and oxygen. We have oxygen, yes. Silicon and oxygen. That is SiO2. That is one molecule of silicon and one molecule of oxygen. Also, we have our common salt. Our common salt is a compound. Common salt is a compound, and the component element of salt, we have the sodium. We have sodium, and we have the chlorine. We have the chlorine and sodium forming our common salt. And the formula is sodium chloride, that is NaCl. Also, examples of compound, we also have hydrochloric acid as a compound. Hydrochloric acid is a compound. And the component element of hydrochloric acid is hydrogen and chlorine, which is HCl, is a component element of hydrochloric acid, and the formula is HCl. These are examples of a common compound. We also have more like the H2SO4, that is hydrogen tetra orthosulfate 6 acid, and many more compounds formed from combination of two or more elements. While mixture is a combination of two or more constituents that can be separated by physical means. Mixture contains two or more constituents that can be separated by physical means. Mixture could be made up by a combination of compounds or elements, but can be separated by physical means. Let's look at mixture. Some common mixture and their constituents. Some common mixture and their constituents. Let's look at air. For instance, air is a mixture. Air contains oxygen, carbon dioxide, nitrogen. It contains rare gas, dust, and moisture. So air contains oxygen, carbon dioxide, nitrogen, rare gas, dust, and moisture. Soil is also a mixture. Soil is also a mixture. It contains sand, clay, humus, air, water, and mineral salts. So soil is also a mixture, contains sand, clay, humus, air, water, and mineral salts. Urine also, the familiar urine is a mixture. Urine contains urea, water, and mineral salts. Urine contains urea, water, and mineral salts. Palm wine also. Palm wine is a mixture. Palm wine is a mixture. It contains water, sugar, alcohol, mineral salts, vitamins, protein, and fats. Mineral salts, vitamin, protein, and fats. White brass. Brass contains copper and zinc. Brass contains copper and zinc. We also have more familiar examples of mixture like the Coca-Cola and many more. Let's look at comparison between mixture and compound. Comparison between mixture and compound. Mixture here could be homogeneous or heterogeneous, meaning that mixture can be formed from as many compound or elements as possible, while compound have to be homogeneous. Mixture are not chemically combined together, therefore they are not represented by any formula, while compound are chemically combined together and are represented by formula. The constituent of mixture can be represented in any ratio by mass, hence they are not represented by a formula. While in a compound, the constituents are represented in a fixed ratio by mass. Also, the property of a mixture are the sum of the individual constituents, while the properties of a compound are entirely different from its constituents, that is, from the elements that form up the compound. That will be all for today. In our next class, we'll be looking at separating techniques, how to separate mixture together, different way, different method we can use in separation of mixture. Thanks for today. Thanks for watching. Kindly support us by giving us a like, subscribe, and share. And don't forget, on Tuesday, we'll be dropping our biology series. On Wednesday, we'll be dropping our physics series. On Thursday, dropping our mathematics series. While on Friday, we'll be for our antique questions and answer. Thanks for watching. Bye.